there. In today's video, we're going to be talking about intermolecular forces. So intermolecular forces are attractions or forces that describe how molecules and atoms interact with each other. Now, dispersion forces are extremely weak attractive forces that are created by the movement electrons. And these movements will actually attract the positive nucleus of another atom. So dispersion forces are basically the attraction between the negative charge of electrons of another atom to the positive charge of the nucleus and the protons of the other atom. And this leads to the temporary dipoles that loosely stick the atoms together. So they have a tendency to come closer because of this attraction, which is the most weak attraction, but it is still present. And dispersion forces are most likely, in most cases, temporary because the electrons are constantly in motion. So they're never in one spot. So it only allows the atoms to form a temporary dipole between this negative charge and the positive charge of the protons. Another thing about dispersion forces are that they are present in both polar and nonpolar molecules. Now, since the attraction is between electrons and protons, another thing to consider is that the more electrons there are, the stronger the dispersion force. With more electrons being present in the atom, it's more likely to be attracted to the nucleus of the other atom. So the more electrons there are, the stronger the dispersion force is going to be. And finally, they're also known as London dispersion forces, named after the physicist Fritz London. Fritz London discovered dispersion forces around 1930. So next we're going to be looking at dipole-dipole interactions. And dipole forces are attraction forces that occur between two polar molecules. So this force only occurs between two polar molecules, and these polar molecules are attracted to one another. Let's look at HCl for example. HCl is hydrochloric acid. And hydrochloric acid has a dipole moment, and that looks like this. This is the hydrogen atom, which is bonded with the chlorine atom, and hydrogen has a positive charge, slightly positive charge, and chlorine has a slightly negative charge. So the dipole moment can be represented like this. The positive end, and this is the negative end. So the dipole force is the attraction between the positive end of one polar molecule to the negative end of another polar molecule. So in this case, hydrogen is the slightly positive polar molecule, and chlorine is a slightly negative polar molecule. So the strong electronegativity of the chlorine actually pulls the electrons away from the hydrogen. So either end of the polar molecule would be attracted to water, which is also a polar molecule. So the two hydrogen positive dipoles will be attracted to the negative dipole in the chlorine atom. So when you put these two molecules together, there will be attraction here. And if there was another HCl over here, then the hydrogen would be attracted to that other slightly negative chlorine. So in larger dipole moments, the larger the attractive force. So dipole-dipole forces are electrostatic. Now let's look at hydrogen bonds. And hydrogen bonds are the strongest of these three intermolecular forces. But keep in mind that hydrogen bonds are not an actual chemical bond. Here we know that the oxygen is slightly negative, while the hydrogen atoms are slightly positive. And between these atoms, the hydrogen bonds are the attractive forces, where the hydrogen is covalently bonded to a very electronegative atom, such as oxygen. Remember that hydrogen bonding always involves a hydrogen atom bonded to some highly electronegative atom, which could be a fluorine, oxygen, or nitrogen atom. So in water, the hydrogen atoms are bonded to a very electronegative atom, oxygen, which has a slightly negative charge, while the hydrogens have a slightly positive charge. And when they hydrogen bond with other molecules, water molecules, this is what happens. So the hydrogen, the positive charge of the hydrogen, is attracted to the negative of this oxygen. So the negative charge of this oxygen and the positive charge of this hydrogen is what causes this small dipole moment and this interaction. But remember, for a hydrogen bond to form, a covalent bond must already exist between a hydrogen atom and a highly electronegative atom. In this case, that's the oxygen atom. H bonds are also very important when it comes to determining the properties of water and other biological molecules, such as proteins. So just to recap, these are our intermolecular forces, 1 being the strongest and 3 being the weakest. Hydrogen bonds are the strongest intermolecular forces, and then there are dipole-dipole interactions, which occur when polar molecules are attracted to one another. And then the weakest intermolecular force being dispersion forces, when the electrons of one atom are attracted to the protons, the nucleus of another atom. So dipole-dipole interactions and dispersion forces are actually also known as van der Waals forces, named after Dutch chemist Johannes van der Waals. So that wraps up our video about intermolecular forces. And if you have any questions, please let me know in the comments. The links to all the resources and books will be linked in the description box. And I hope you found this video helpful. Thank you for watching.